So today we get to look at the different configurations of current and the magnetic fields that result. The first of these is a loop of current. Now we only have a semicircle, but it will give the same results as if this loop made a full circle. So we'll just imagine that. And we can see that at the outset we've got 1, 2, 3 compass needles. The silver edge of the compass needle is pointing north. That's again towards Hoboken, New Jersey in our classroom. And there is no current flowing currently. I guess I should say presently. So let's take a look at what happens when I do send some current through. You'll notice the compass needle in the middle changed 180 degrees. Even a little, or thereabouts, maybe something like 150 degrees. Right? Whereas the ones on the side, let's take a look at those again, they change by something like 30 degrees. The one on this side may be easier to see. It changes by about 30 degrees. That tells us that the field outside of the loop is oppositely directed than the field inside the loop. Let's think about how that would work using our second right-hand rule. If the current were flowing this way, then inside the loop, my fingers pointing in the direction of the field would be that way, and outside the loop, my fingers are pointing in the direction of the field towards the top of your screen as my fingertips are pointing in the picture. So let's think about, is that the correct way for the current to be shown? Let me show this to you one more time. We see that north is the silver side of our compass needle. My compass got reversed as I moved things about. And when I allow current to flow, the south side of the compass needle is pointed in the direction towards my finger in the picture. So pause on that for just a moment and think about what the direction the current must be in. If you can go back and still that picture, that would probably be a great idea. And I'm back, and I hope you are too. Having paused, let's think about what that direction of that current must be. Well, right now, and we're back. Right now, the north side of the magnet, that is the compass needle, is pointing right towards my finger. When I allow the current to flow, that side of the magnet is pointed in the opposite direction of what it was without the current, which must mean that the north side of the magnet is pointed towards the south pole of the field. The south pole of the field, then, is where my fingers are pointing, and in fact our direction of current ought to have been just as we see going from right to left in your picture. So think about that one for a moment while you pause. I'm going to get a different configuration. Of course, you can continue right along with the video once I'm back. And we are back with our new configuration. This is called a solenoid. And a solenoid is a series of coiled wires. Those coiled wires, as you can see, once again have our compass needles in them, and there is presently no current flowing through those compass needles. However, when I do allow some current to flow, once I get my camera in position here, we can observe that inside the solenoid, there is a very profound change in the direction of the compass needle. Outside the solenoid, also a profound change in the direction of the compass needle, but in the exact opposite direction. I've released the current and gotten my compass needles back to their original positions, and now when I press that current through, we notice especially the central one really snaps very hard to be about 45 degrees out of its original position. Inside this solenoid, as we'll see in a separate video, there are fields being created by every bit of current everywhere along this wire, and it adds up to pack quite a wallop on the inside and give us something else quite unusual about the inside of a solenoid. So look to the next video for that information. Thank you.